Good morning, students. Today we are going to read the third lecture in the topic of laws of magnetism and magnetic properties of matter. And today's lecture, the title is Magnetic Fields. So concentrate yourself. We are going to start now. The region around a magnet where the magnetic force can be experienced is known as the magnetic field. So this is the definition of the magnetic field. So concentrate. This is the region around a magnet where the magnetic force can be experienced is called magnetic field. There are two ways to observe or draw the magnetic field of a bar magnet. So this is very important question. So concentrate yourself using a plotting compass. Place some small plotting compasses near a weak bar magnet, preferably on an overhead projector. So look now, some small plotting compasses will be placed near a bar magnet. So the compasses point along curved lines as shown in the diagram. So the curves, the plotting compasses will take a shape that will be like this. So the compasses point along curved lines as shown in the diagram. These lines are called lines of flux or lines of the force or field lines. So there are three names for the thing. These lines will be called lines of flux or lines of force or field lines, and they show the direction of the magnetic field at each point. To plot a magnetic field with small compasses. So this is an other explanation of the same thing. So look now, put a bar magnet onto a sheet of the paper and place a small compass. So now one small compass will be used near to the magnet, position 1. So look now, this will be the position 1. So we will put one small compass at position 1. When the compass has settled, mark the ends of the needle with pencil dots. So we will place pencil dots over here. Then move the compass to position 2 so that the south pole resets, rest on the dot which previously marked the N pole. So look now, this will be the position of the second position at which the compass will be put. So again, put a third dot against the N pole. So we will put a dot again. Move the compass on the position number 3. So we will move the compass to some extra distance towards here and repeat the procedure. Continue this until the compass reaches the south pole of the magnet. So gradually we will move compass further, and finally the compass will come to the south pole of the magnet. Then join the dots. The line produced represent a line of the force. Repeat the whole operation for other lines of the force. The advantage of this method is that the direction in which the north pole of the plotting compass points indicates the direction of the magnetic field. So this will be the direction of the magnetic field. Okay, the next thing that we are going to read in the lecture is to show the lines of the force. Place a strong bar magnet on a cork floating in a dish of water. The cork rotates or oscillates until the magnet comes to rest pointing in a north-south direction. Magnetize a long steel needle so that the eye is a north pole and the point a south pole, and push it through a small cork so that the eye is just above the cork. So look now, it will be pushed through a small cork. Here is a small cork now. The eye of the needle is north pole and the point is south pole. So push it through a small cork so that the eye is just above the cork like this. float the magnetized needle in the water. So allow it to float. The south pole is far enough away from the surface of the water. So here is the south pole, far away from the surface of the water, for the north pole at the eye to act like a free north pole. So this north pole will act as a free north pole now. Place the floating needle near the north pole of the magnet and release it. So we will place the north pole of the magnet near to the north pole of the needle and free it then, release it then. It should follow the path indicated in figure below. So it will follow the path like this. The path traced by the moving needle eye is a line of the force. So this will be the line of the force. A different path will be traced if you place the needle in different starting position. So definitely if you change the position of the needle, so the pathway will be different then. Here is another method that is called using iron filling method. This is much easier method. Look now. Place a sheet of the paper over a bar magnet. So here is a bar magnet. So put a sheet of the paper on it and then sprinkle a thin layer of the iron filling over the paper. So here is a iron filling. Sprinkle it uniformly and then tap the paper gently like this. We will tap the paper. The iron filling act like thousands of the tiny compasses and group themselves along the magnetic field lines. The magnetic field pattern is formed with no indication of the direction. So this pattern will be formed. This is called the line magnetic field pattern. Here is a question related to the topic, that is, describe how to plot the magnetic field around a bar magnet using iron fillings. This normally carries 4 marks. So look now, the point to be written in the paper. Place a piece of the paper on the top of the bar magnet. It will have 1 mark. Sprinkle iron fillings uniformly, thinly and evenly over the paper. This will have 1 mark. Give the paper a gentle tap like this one. This will have 1 mark. And draw the field patterns on the paper along the lines of the filling. So this will have 1 mark. So this is the distribution of the marks for these points. So this question comes frequently in the paper. Okay, moving further. Magnetic line of the force is that it is the path in which the imaginary free north pole will travel if it is free to do so. However, free north poles do not exist. Magnetic poles are the places in a magnet to which magnetic materials are attracted. These are north and south poles. For example, iron fillings attract towards the poles of the magnet. They are near the ends of the bar magnet and occurs in pairs of equal strength. The next thing that we are going to read is the properties of the magnetic field lines. So again, very important short question that frequently come in the paper. The direction is always from north pole towards south pole. They do not cross or intersect one another. They repel one another sideways. They are in a state of tension which causes them the tendency to shorten themselves. And the region with the higher density of the lines has the greater magnetic field strength. So more the lines are there, more the density of the lines are there, the greater will be the magnetic field strength. So these are the properties which are very, very important. So first property, the direction is always from north to south pole. Second, they do not cross or intersect one another. Number 3, they repel one another sideways. Next, they are in the state of tension which causes them the tendency to shorten themselves. And finally, the region with the higher density of the lines has the greater magnetic field strength. Two very important magnetic fields are: number one, the uniform magnetic field, in which the lines of the force are parallel, straight lines, and equal distance apart. And number two, the radial field, in which the lines of the force spread out from a point rather like the radii of the circle. So look now, here are these two types of the uh, magnetic field lines. The magnetic field is stronger at A and B. So these are the points at which the magnetic field is stronger. A uniform magnetic field. So in this a uniform magnetic field is there. Examples of the magnetic field pattern. So when same poles are placed side by side, look now, use iron filling method to find the shape of the magnetic field around two magnets with the like poles placed near each other. At point P, where there is no magnetic effect at all, is known as the neutral point. So this is the neutral point at which no magnetic effect will be felt. So this will be the pattern when two same poles are placed side by side, because the magnetic fields start from north pole and end at south pole. So this will be the pattern. So this will be the pattern. Two magnets with unlike poles placed near each other. So look now, two opposite poles of the two magnets are placed side by side. So the magnetic field start from north pole and end at south pole. So look now, this will be the pattern now, and here is the north pole. So this will be the pattern. Two parallel magnets with like poles facing each other. P represents neutral point. So look now, the two magnets are placed in parallel with same poles facing each other. So north pole to south pole will be the direction of the magnetic field lines. And P is the point that is called neutral point, because at that point no magnetic effect will be felt. And two parallel magnets with unlike poles facing each other. So look now, two parallel magnets with opposite poles facing each other. So now the magnetic field lines will start from north pole and end at south pole. So look now, this will be the pattern, and from here, again from here, and this is north, this is south. So this will be the direction of the magnetic field lines. It is a short question. What do you understand by the term neutral point? A neutral point is defined as the point at which the resultant magnetic flux density is zero. The next thing that we are going to read in the lecture is the Earth's magnetic field. The Earth has a magnetic field. No one is sure of its cause, although it is thought to come from electric current generated in the Earth's core. Such currents are thought to be generated by convection in the Earth's liquid core. The energy for convection is thought to be due to the conversion of nuclear energy brought about by radioactive processes in the core. The field is rather like that around a large but very weak bar magnet. The north geographical pole has south magnetic polarity, since it attracts the north pole of the magnet. The south geographical pole will have the north magnetic polarity because it attracts the north pole. With no other magnets near it, a compass needle lines up with the Earth's magnetic field. The north of the needle points north, but an north pole is always attracted to a south pole. So it follows that the Earth's magnetic south pole must be in north. It lies under the point in Canada called magnetic north. Magnetic north is over 1200 kilometers away from the Earth's geographic north pole. This is because the Earth's magnetic axis is not quite in line with its north-south axis of the rotation. So these are not important points as far as your papers are concerned. Okay, magnetic field can also be found in the interior of the atoms and in stars and other celestial bodies. A compass is of no use in polar regions because the Earth's magnetic field lines are vertical. So this is very important point to be noted. The compasses are of no use in the polar regions because the Earth's magnetic field lines are vertical there. Since a free suspended magnet always comes to rest position pointing towards the North Pole, it can be used as a compass. The needle of a compass is a magnet that can spin freely about a point, the arrow of the needle being a north pole. A compass needle is a small magnet free to rotate in a horizontal plane, so it aligns itself in north-south direction. At most places on the Earth's surface, a magnetic compass points slightly east or west of true north. That is, the Earth's geographical and magnetic north poles do not coincide. So this is the reason that at most places of the Earth's surface, a magnetic compass points slightly east or west, not exactly in this north direction. It slightly points towards east or towards west because Earth's geographical and magnetic north pole do not coincide. The angle between the magnetic north and the true north is called the declination. So, as you have learned, as you have read, the reason that Earth's geographical and magnetic north poles do not coincide, so it means there will be a difference in the angle between the true north and the magnetic north. That difference is called declination. So this was the lecture, students. I hope so this will be much easier and interesting for you to understand now. So read this lecture again, understand it, learn it, and make your notes. Thank you so much.